This is Lab 1, Constant Velocity Motion by Jess Baker, Lab M01, Monday, 12 to 3. So what we did was we took a video of a motion. I did it of a rolling jar of jelly, modeled it with VPython, and then predicted the motion with a model by using Newton's second law. We were trying to prove that the F net equals 0 in the model, and it provided a good prediction of the observed motion, showing that the F net is 0 in constant velocity. Here's my clip, and as you play it, you can see that the jar rolls along the x-axis. I set the origin at the center of the jelly jar, and it moves along the x-axis. And each point is the marked center of the jar, at each clip. And the calibration stick is set on the diameter of the jar of jelly to show the length of the jar. There were 12 frames. Each frame was 0.069 seconds long. So that was the model clip, and then here's the modeled motion. So it moved in the positive x direction, and it modeled Newton's second law, and as you can see here, the ball started at the origin and the velocity was positive 2. We found the velocity by using this model. The initial velocity should be the same as the final velocity since it's a constant velocity. And we found that by using the change in position over the change in time. From the tracker data, the change in time was the whole clip, and the change in position was from the beginning of the clip to the end of the clip. And we got 0.211 velocity. And then the observation time was about a second. And then the model used this equation, and it showed that the final velocity equals the initial velocity, and therefore this right here must equal 0. And for this to equal 0, we know the delta t is not 0 and the mass is not 0. Therefore, the F net must be 0. So, what if we move the motion in the x direction? Does the graph become more negative? Let's see. Right here, we can change the ball velocity to negative and rerun the module and see what happens. Now it goes in the negative x direction. So what does this mean? When the velocity is negative, the position also becomes negative. So with the constant velocity, that means the total pushes and pulls are equal to 0. So if the force is not equal to 0, is the velocity also not equal to 0? Let's see what happens when we change the F net vector. So if we change it from 0 force to a force of 2 in the x and y direction, let's see what happens now. So now the ball accelerated upwards and to the right, which implies that when the force is not equal to 0, the velocity is also not equal to 0 as shown by the model. This graph shows that the model was an accurate model since it ran the same track as the clip.